Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, IPO. So what this problem says is basically, suppose Leetcode is going to IPO soon, and we want to sell a good price of its shares to VCs. Essentially, you can ignore all of that, but basically we have some projects, that's the gist of it, where we want to increase our capital as much as possible using these projects. And these projects each have a profit, right? And when we do a project, we get that profit. And that profit, each project also has a minimum capital that we can't do that project unless we have that capital. Now, one weird thing about capitals for this problem that you need to pay attention to is that if you have capital and you do a project, let's say this one, you don't actually consume one capital. So you don't subtract this value from your overall capital value. This is just how they laid out the problem. So you only add the profit of 2. Let's say your capital was 0 and you do the project at index 1. You would add 2 to your overall capital, but you won't subtract this one. Now, you can't, in this specific case, because the initial capital is 0, you can't start with this one because it's bigger than your current total available capital, right? So this array of capital is only used to make sure that you do a project only if you have enough capital for it, right? So that's the distinction there. Now, you can do at most k distinct projects. And the goal of the problem is to maximize the final capital we have, right? So we have two, for example, in here we can do at most 2 projects. Initial capital is 0, and these are the profits and the capital of the project. And so with the constraint that we can't do a project unless we have enough capital, the only one we can do here is the first one because it has capital of 0. We can't do these 2 because they require at least 1 capital of 1. Okay, so once we do the first one, we get a profit of 1, so our capital is now 1, and now we have the choice to do one of these 2. Now in this case, which one is better? Well, we want to maximize the profit, so we should take the one with the highest profit, and so that's 3 here. Okay, and so the total would be, first we take the profit of 1, and then we take the profit of 3, and we stop because we have only 2 projects to take, right? And so that would be 0 plus 1 plus 3, and this is the final profit we take. Okay, so that's roughly the idea. Now let's see how we can solve it. Take the first example. We start out with the initial capital of 0. And so initially, the only one we can take is the first one, right? Because we can't take these 2. And so you see that constraint that we can't take these 2. And so there is already the constraint of we take only if, let's call the current capital, right? And so we can take only if C value is smaller or equal to capital. Okay, so we have that constraint there. And so let's say we take the first one. So we take 0 here. And now our capital is going to be equal to the profit because we add the profit, so value of 1. Okay, so now we only have these 2 remaining. And we choose the highest profit, right? So here it happens we have 2, so it's easy, but if we have a lot more, 5 or 6, we want to add them in some way to something so that we can pick the highest value. And whenever we have that, we need to think about using a priority queue, right? The other problem is, what if because of the capital we had to skip? So let's say, for example, we have these projects. So let's say our profit and our capital is, first we have maybe 2, 3, 2, and then we have here 0, 1, 2, and then the projects, let's say we have 3, 2, 3, and then for this one we have maybe 3, right? And then here it doesn't matter, 4, 2, right? So let's say we have these projects here. Now we start out with capital, let's say equal to 0. So our capital first is 0. So what happens? We only can take this one. So we have to take this project. So we take it, we get profit of 3. So now our capital is 3. Okay? And so now which one we take, right? We need to keep track of all of the ones we can take, right? Because we can take this one because our capital is 3. We can take this one, we can take this one, we can take this one. Sorry, actually, we need the capital to be smaller than 3. So we can take this one, this one, this one, this one, this one. So we can take all of them, but we need to organize them by profit, right? And so we need to do 2 things. First, for the initial capital, we need to sort the combination by capital so that we can get the smallest capital, because that one has the highest chance of being smaller than our current overall capital, right? And so we need to first sort by capital, right? But in that list, right, we want to store all the profits that are smaller than the current capital so that we can pick among those, we can pick the maximum one, right? And so what do we need for that? We need let's call it a priority queue, right, by profit. Okay, and this one will contain only those that have capital smaller or equal to our current capital value. And if we do this, we should be able to solve the problem, right? So let's actually run it on an example here. So let's run it on this simple one first. Okay, so with this array, our capital is going to be initially 0. So first we want to sort the pair, right? And so let's call this just, let's call it P, because it's going to be a combination of both. So we would have 1, 0 for the profit in the capital, and then 2, 1, and then 3, 1. Okay, and now we want to sort it by capital, right? Here it happens that it's sorted by capital, so we are fine. And then we want to go through them, and we want to fill the priority queue as long as it's smaller than the capital we have, right? And so what we do there is we get the first one, right? And then we add it to our, since it's smaller than the capital we have or equal to the capital we have, which is 0, we add it. And so now we have in our priority queue, we only need the profit. The capital, we only use it to check. So we only need to add the profit. So we add the profit, which is 1. And now we stop because the next one is bigger than the current capital. So the ones after that would be bigger because this one is sorted. So we just stop there. And now we look at our priority queue. And we add that value to our capital. So our capital is now equal to 1. Okay, and we remove it, right, because we added it to our capital. So now our priority queue is here, and now we go again to our list of projects, and we check, is this smaller than the capital we have? Yes, so we add it to our priority queue. We want to add only the profit, so 2, and we check this, is this one smaller or equal? Yes, so we add the profit there as well. And now we go through the priority queue and pop the highest value, so we pop 3. So we pop 3, we add it, now our capital is 4, but remember, we want to do this only for at most k distinct project. And so now since we added 2, we stop. So we do it only for k projects. So that's roughly the idea. Sort by capital first, and then each time, for each project we want to pick, check the ones that are eligible, add them all to a queue, and then pop only the one with the highest value, and then do the same again, right? Okay, so that's roughly the idea here. Now let's implement it and make sure it passes test cases. Okay, so let's implement what we saw in the overview. So what we need first is we need a sorted list, we said, for profits and capital. So this would be our projects, and we want to sort it by so this will give us a pair of the profit and the capital, right? And so we sort it. What do we want to sort it by? We want to sort it by capital. And so for that, we want to use a key because that's not the default sorting. And so what would be the one we sort by? It's capital, which in a pair of profit and capital, it would be in position 1. And let's call these projects, right? Now, each time what we do is we just get the first element. So we get we can have definitely like an index right? So let's say we have in our case 0, we had 2, 1 in the example we saw. So we can have an index that just keeps track of where we stopped at, but it's easier actually to just have a DQ so that we can pop from the beginning. So we pop this one once we process it, and then we pop this one once we process it. That way we don't need to maintain an index. And so that's actually what we can do here. We can just pass this to a collection DQ, and this will give us the ability to pop from the front. Okay, so now after that, what we need to do is we just need to have the initial capital set to W. And we need our priority queue that we will add eligible project to. And so let's call that priority queue. And now we want to do this. We want only K, at most K projects. So we want only K. The only caveat here is, what if K is bigger than the number of projects we have? Let's say K is 4 and the number of projects is 3. What do we want to do in that case? Well, in that case, we want to take only 3, because if there are no projects, we can't take them. The problem also says at most K. And so an easy way to solve that is just to say K is equal to the minimum of K and the length of the number of projects, which is just the length of the profits. So that would would solve for that case. And now what we want to do is basically add all eligible projects to a queue, right? So to a priority queue, so that we can take the highest profit. Because we want to maximize the profit, but we also want to maintain that we can't take more than the capital we have. And so to do that, so while we have projects, of course, and the project in the front, which we want to check the capital of it, which is at position 1. So for example, here we want to check, let's say when we had 1, 0, 2, 1, we want to check that this here is smaller or equal to the capital before popping it off. So we check if it's smaller or equal, then we want to add it to the list of eligible projects. Let's actually call this eligible because that would make it more readable. And so here we want to add it, but because we want to get the highest profit value, we want to make it a priority queue and add here just the profit value. And so that would be just projects. We want to pop the front now. And so this will give us the pair. And we want to take the profit value, which is at position 0 here. So that's what we'll take. Let's call this, for readability, project. And let's just take the profit of it, right? Or we can even say this is profit and capital, and then just take the profit here. Okay. Okay, so now once we push that, what we need to do next is, if there are eligible project, we want to take the highest one as this projects, right? We want to do it only K times, and each time we take one project. Okay. And so here when we take a project, when we do a project, we add the profit, and the profit is just the heap queue. We want to pop the highest profit value, so that would be just among eligible ones. And then at the end, we want to return the final capital. Okay. Yeah, so here, just to make sure we don't override this list value here, let's call this C, and let's call this P. Now, one thing to note here is that since this eligible here in Python is going to be by default a min queue, and so by default, if we add just the profit value as it is, it's going to give us the smallest one. So we want to get the maximum one. So we just add minus so that the smallest one is actually the highest one. And when we want to add it here, when we pop it, we want to put -1 in front, right? So that's just for Python to get a max heap. And now if we run this, looks good. It passes our test cases. Now let's add the minimum, taking the min, and this passes fine, right? Cool. So that's pretty much it for this problem. It's a pretty good application of priority queue. Yeah, please like and subscribe, and see you on the next one. Bye. That should be it. Let's run this.